Hello students, welcome. Previously, lesson 7, form 4 topic 5, we were dealing with the second part of the chemistry of iron metal. So today, lesson 8, we want to proceed to the fourth metal, that is the chemistry of zinc metal. So in this class, we are going to do the occurrence of zinc metal and also the extraction of zinc metal. So kindly stay with us until the end of the video. So to start with the occurrence, we are saying zinc occurs as zinc blende, and zinc blende is zinc sulfide. Its chemical formula is ZnS. So we said zinc also occurs as calamine, and calamine is zinc carbonate, and its chemical formula is ZnCO3. So zinc also occurs as zincite, and zincite is zinc oxide, and its chemical formula is ZnO. And we're saying the chief ores from which zinc is extracted is zinc blende and also calamine. So let's go to the extraction of zinc metal, and we're saying zinc is extracted by both the reduction of zinc oxide using coke and carbon 2 oxide as a reducing agent in a ballast furnace and electrolysis of dilute zinc sulfate solution. So next we are saying the zinc plate O contains impurities such as galena, and galena is lead 2 sulfide, and its chemical formula is PbS, and silica is silicon peroxide, and its chemical formula is SiO2. So let's proceed to the extraction process of zinc metal, and we're going to start with part 1, that's crushing of the ore. And we're saying the ores of zinc is ground into fine powder so as to increase the surface area for the extraction of zinc. So number 2, we are going to go to concentration of the ore, and the aim is to remove impurities, and we're saying the zinc blende is concentrated using froth flotation. So how? So we're saying the zinc blende is ground into fine powder, then mixed with water containing special oil such as pine oil as frothing agent. Froth, rich in minerals, is formed at the top, while impurities sink at the bottom. The froth is skimmed and dried. So number 3, we are going to proceed to the roasting of the concentrated ore, and we're saying the concentrated ore is then roasted in air to form the metal oxide. So in the case of calamine, zinc carbonate decomposes to form zinc oxide and carbon peroxide, and the question for that reaction will be zinc carbonate solid being heated or roasted in air, forming zinc oxide and also carbon peroxide gas. And remember, when a carbonate is heated, we get metal oxide and carbon peroxide as the only products. So in the case of zinc blende, we are told 2 reactions occur. So the first reaction will be, we're told zinc sulfide is roasted in air to produce zinc oxide and sulfur peroxide gas. So the question for that reaction will be 2 moles of zinc sulfide solid reacting with 3 moles of oxygen gas will be getting 2 moles of zinc oxide and also 2 moles of sulfur peroxide gas. The impurity, the 2 sulfide, remember we're told zinc blende often mixed with galena, and galena is lead 2 sulfide. So the impurity lead 2 sulfide in the ore is roasted in air to produce lead 2 oxide and sulfur peroxide gas, and the question for that reaction will be 2 moles of lead 2 sulfide solid reacted with 3 moles of oxygen gas will be getting 2 moles of oxygen gas and 2 moles of sulfur peroxide gas. And in general, we are told when metal sulfide is heated in air, we are going to get 2 products, which one of them is metal oxide and the other one is sulfur peroxide. So you have to know, learners, the main pollutant in the extraction of zinc is sulfur peroxide. And we're saying the sulfur peroxide gas produced is an important byproduct which is used in the manufacture of sulfuric acid in the contact process. So next we are going to go to number 4, that's reduction of the ore, and we are told zinc may be obtained from zinc oxide either by reduction using coke and carbon 2 oxide as the reducing agent, or it may be converted to zinc sulfate and electrolyzed. How are we going to convert zinc oxide to zinc sulfate? By just reacting with dilute sulfuric 6 acid, so that zinc oxide reacts with dilute sulfuric 6 acid to form zinc sulfate and also water. So that zinc sulfate solution will be electrolyzed to obtain zinc metal. So let's start part A, that is reduction method using carbon and carbon 2 oxide as the reducing agent. And we're saying reduction is carried out in a ballast furnace relatively similar to the one used in the extraction of iron metal, but is smaller in size. So let us see the ballast furnace. So this is how it look like, the ballast furnace in the extraction of zinc. So we are going to have here the ballast of hot air, and here we are having zinc oxide, coke, and limestone being fed at the top of the furnace. So just like the way we were doing iron, so here we are having zinc vapor, remember. So we are going to have here condenser. In the condenser we have molten lead. We are having here the separator. This separator, we are going to separate the mixture of lead and also zinc, and we are told zinc is less denser than lead, so zinc will be floating on the surface of lead where it is tapped off here. So remember, here we are having slag and also molten lead, and slag is less denser than the molten lead, and we are going to see the reason, because slag is less denser than the molten lead. So slag will be floating where the two of them are tapped off periodically. So we are saying the zinc oxide O from the roaster is mixed with coke and limestone and fed at the top of the ballast furnace. A ballast of hot air is forced near the bottom or the lower part of the furnace, and we're told here oxygen reacts with hot coke, forming carbon 2 oxide. So we're having 2 moles of coke or carbon solid reacting with 1 mole of oxygen gas, giving us 2 moles of carbon 2 oxide gas. And we're told this reaction maintains the temperature of the furnace to about 1000 degrees Celsius. So next we're told coke, that is carbon and carbon 2 oxide, reacts with zinc oxide from the roaster, reducing it to metallic zinc. The question for those reactions will be zinc oxide solid reacting with coke, giving us zinc in a gaseous form and carbon 2 oxide gas. So the second question will be zinc oxide solid reacting with carbon 2 oxide gas, giving us zinc in a vapor form and also carbon dioxide gas. So next we are saying the carbon dioxide is reduced by coke to carbon 2 oxide. So the carbon dioxide that we are getting here will be reduced to carbon 2 oxide by the coke. And the question for that reaction will be carbon dioxide gas reacting with coke solid, giving us 2 moles of carbon 2 oxide gas. So next we are saying the carbon 2 oxide and the coke are the reducing agents, but carbon 2 oxide will be the main reducing agent because of the large surface area which is in contact with the zinc oxide. So next we are saying zinc has a boiling point of 913 degrees Celsius at the furnace temperatures, which are maintained above 1000 degrees Celsius. Zinc exists in a vapor form. So learners, during the exam you can be asked to state the physical state of zinc in the furnace. So the state of zinc in the furnace is in a vapor form or gaseous form. So I told the zinc vapor lives at the top of the furnace with the hot gases. Remember the hot gases that we were talking about when we were reading the chemistry of iron? They were including carbon 2 oxide, carbon dioxide, nitrogen gas, and also nitrogen oxide gas. Those are the hot gases that we are talking about. So I thought it is cooled very rapidly to 600 degrees Celsius by mixing it with a spray of molten lead. So what is the role of the spray of molten lead? We are told the lead spray condenses the zinc. That's the first role. And the second role is and prevents it from being reoxidized. Those are the two functions of the lead spray or the spray of molten lead. So next we are saying at this temperature, liquid zinc separates and settles above the molten lead. We are talking about after it has been cooled very rapidly to a temperature of 600 degrees Celsius, because when the temperature is 600 degrees Celsius, remember zinc will exist in a liquid form, not in a vapor form, because the boiling point of zinc is 913 degrees Celsius. So at around 600 degrees Celsius, it will be in a liquid state. So I told at this temperature, liquid zinc separates and settles above the molten lead since it's less denser and it runs off. So we're told zinc can be purified by distillation method because that zinc contains impurities like the molten lead. So for us to get now purified zinc, it can be purified, or more pure zinc, it can be purified by distillation method. So next we are saying in the furnace, contaminating lead 2 oxide is reduced by coke and carbon 2 oxide to metallic lead. Remember, when we are talking about the zinc blend, we said in the roasting chamber, we are told zinc sulfide will be roasted in air to obtain zinc oxide and sulfur peroxide. So the impurity lead 2 sulfide also will be roasting in air to obtain lead 2 oxide and also sulfur peroxide. So that lead 2 oxide is the contaminating that we're talking about. The contaminating lead 2 oxide in the furnace is reduced by coke and carbon 2 oxide to metallic lead. And we're told at this temperature of the furnace, lead exists as a liquid, not as a vapor like zinc. So the equation for that reaction, we're going to have lead 2 oxide solid reacting with carbon 2 oxide gas, giving us molten lead and also carbon peroxide gas. And we are told the lead produced during the extraction is a liquid at the furnace temperatures, and it trickles to the bottom of the furnace from where it is tapped off. So we are saying the limestone fed into the furnace alongside coke and zinc oxide is decomposed by heat in the furnace to form calcium oxide and carbon peroxide. So the equation for that reaction will be calcium carbonate solid decomposes to form calcium oxide and also carbon peroxide gas. So you're saying calcium oxide formed being basic reacts with the impurity, that is acidic silicon peroxide, in the furnace to form calcium silicate. So the equation for that reaction will be basic calcium oxide solid reacting with acidic silicon peroxide solid, giving us calcium silicate, which is molten in the furnace. Where two calcium silicate produced form slag. The slag formed is tapped off at a higher level of the furnace because it is less denser than the molten lead. Let's proceed part B, that is electrolytic extraction of zinc using dilute zinc sulfate solution. And we're saying the zinc oxide obtained from the roaster is converted to zinc sulfate by reacting it with dilute sulfuric acid. And the equation for this reaction will be zinc oxide solid reacting with dilute sulfuric acid, giving us zinc sulfate solution and also water. And I said any lead 2 oxide present reacts with the acid to form lead 2 sulfate, which is insoluble and it is therefore precipitated. So here we're saying the equation for that reaction will be lead 2 oxide solid will be reacting with dilute sulfuric acid, giving us insoluble lead 2 sulfate and also water. We are told pure zinc powder is then added to the product to precipitate less reactive metals, especially lead. So we're saying the mixture is then filtered, leaving a relatively pure zinc sulfate solution, and we're told the zinc sulfate is then dissolved in water and the solution is electrolyzed. So if we want to do electrolysis method, we are told the cathode is made of aluminum sheets and the anode is made of alloy of lead and silver, and we are going to have that alloy 99% lead and 1% silver. So let's start at the anode. We are saying the electrolyte that we are having here is zinc sulfate solution, dilute zinc sulfate solution. So it is non-binary electrolyte, so it has more than 2 ions. So we are going to have zinc ion and also hydrogen ion, as well as sulfate ions and also hydroxyl ions. Those are our ions. So sulfate ions and hydroxyl ions are negatively charged and ions, they will be migrating towards the anode. But which one of them will be preferentially discharged at the anode? We are saying hydroxyl ions are discharged at the anode, forming oxygen gas and water. So the question will be 4 moles of hydroxyl ion solution losing 4 electrons to form 2 moles of water, which is liquid, and also 1 mole of oxygen gas. So we proceed to the cathode. So we're having here zinc 2 ions and also hydrogen ions, which are positively charged cations. They will be moving towards the cathode. And we are told which one of this will be preferential discharge. Zinc ions are discharged at the cathode, forming pure zinc, which is deposited over the aluminum sheets. So the question for that reaction will be 2 moles of zinc 2 ions solution will be accepting 4 electrons lost from the anode, giving us 2 moles of zinc solid. And we're saying if graphite electrode were used, hydrogen gas will have been evolved instead of the zinc. So we are not using inert electrodes, instead we are using aluminum sheets. So zinc is stripped off of the cathode regularly, and the metal is about 99.5% pure. So last, let's go to the flow chart showing the extraction of zinc metal. We first of all start mining of the zinc ore, then we will go to the purification, and remember we are going to purify by froth flotation. Then next we are going to go to roasting of the ore in air, and here we are going to get metal oxide, that is zinc oxide, and also sulfur peroxide. So these gases that we have is sulfur peroxide. So here the zinc oxide that we have, we can do in 2 ways. So we have 2 parts here, part 1 and part 2. So in part 1, what we can do is we can take this zinc oxide, then we dissolve in dilute sulfuric acid so that we get zinc sulfate solution. Then after that, we are supposed to do electrolytic method or electrolysis method. In doing so, we are going to get 99.5% zinc. So the second part here is that the zinc oxide that we have obtained in the roaster chamber will be reacted by coke or carbon 2 oxide as a reducing agent, and we are going to do reduction method. So here we are going to get zinc solid or zinc metal. So learners, that is the end of our class today. Thank you for watching.